Okay, so we're going to go over how to graph a function from given conditions here. Right, so let's say we have a list of conditions. In this case, there's quite a bit of conditions here, right? Now, one thing is, at first, you're like, well, how do I even get started with something like this, right? Now, the first thing that I like to do is I like to just look at mainly if I have any, excuse me, any function values, right? And I see that I do have one, right? G of 0 equals to 0. So that means that what this is telling me is that this point is definitely on the graph, the point 0, 0. So I'll just start off by marking that here on my x and y axis. And that point is on the graph. Okay, so that takes care of this condition here. All right, now the next thing is whenever I see these limits that go to infinity, right, not at infinity, but the limit that is infinite, right, this one, this one. So right away, what that is telling me is that I have a vertical asymptote, right? Doesn't matter if it's left, right side, right? If it's infinity or negative infinity that the function is going to, I know right away I have a vertical asymptote. So here it looks like I have 2, right? I have a vertical asymptote at negative 2, right? Now the left and the right limit go in opposite directions, right? But it's still a vertical asymptote, right? And I also have one at 3. Right? Okay, now another thing that I like to do here is just kind of, again, I'm not going to do everything all at once or just connect everything all at once, but just to kind of get a trace of what things are kind of doing here, right? So at negative 2 from the left side, right? From the left side, it's coming down from infinity or going up to infinity. So I just like to kind of do that, right? Again, it's just a trace here. All right, and on the other side, from the right side, it's going down to negative infinity. So I'll do something like this, right? And again, just a trace, right? So I know that that's where it's headed to. All right, so I've gotten through the vertical asymptotes. Now, another thing here is we're given the limits at infinity, right? So at negative infinity and at infinity, I know the behavior of the function, right? And again, what these are telling me is that these are horizontal asymptotes. All right, again, these vertical asymptotes, right, when we have an infinite limit, limits at infinity, if it's a finite value, are vertical, horizontal asymptotes, excuse me. So let me draw those in, right? So we have one at negative 1. And again, we're okay to cross the horizontal asymptotes. That's not a big deal. So I'm just kind of trace them in here at negative 1 and 1. Right, and again, as it goes to negative infinity, we get a value of negative 1, right? And again, what I like to do is just kind of fill in the end behavior, right? Again, I'm going to put everything together at the end. So this is what it does at negative infinity. It's going towards negative 1, right? And to positive infinity, it's going to go to 1. All right. Oh, and one thing I did forget here, I forgot to kind of fill in my trace for the limit as x approaches 3, right? And as we saw from the conditions, that goes to negative infinity, right? Two-sided limit, so on both sides, we have it coming from this direction. Okay, so now we've accounted for, let's see, we got this condition, this condition, this condition is accounted for, this condition, this condition. All right, so now the only thing left here is what happens at 0, right? So I know the function value, right? But again, function value and limits are two different things, right? The function value is what happens at 0. The limit is what is happening around 0, okay? So here looking at the limit at 0 from the right side, right? So on the right of the y-axis, it is approaching a positive 1, right? So approaching. So what I'll do is open circle, right? And I'll just do a little something like this, right? It's going down because I see the part of the graph here, but again, there's no information telling me that's coming from above or down. I'm just kind of putting a little trace there, right? Now, it's important here that it's not just an open circle, right? It's a limit, right? So it's the values near 1 on the right side. Okay, so that has to be part of your graph, right? It's not just an open circle, right? It's the values around it as well. All right, so now if we look at -1, all right, on the y-axis, we see here that's where the function approaches it as it gets closer to 0 on the left side. And again here, right, values as it gets closer, right? It's not just an open circle. Okay, so let's see what we have so far here. All right, so looking at this, let me adjust my camera here. You can get it. Okay, all right. So looking at this here, I've accounted for all of my conditions. All right, the only thing left is to kind of put this together here, right? Because this just kind of out into space, not going anywhere, and I don't want that. So one thing I can do here is we could say, all right, we'll do that right there. This can go there, right? And then over here, does something like this, and then up here, it does something like that. Okay, now the last thing here, and I see this mistake often, is I just kind of see lines going everywhere. This is asked for a function. So what are the characteristics of a function? It needs to pass the vertical line test, right? And this one does, right? The vertical line test, it can only hit the graph at most once. All right, and then here, even at the y-axis, again, still only once, right? Because the only function value, the only point there is 0, 0, right? These values of 1 and -1 are not attained. They're approached, but not attained. Okay, so there we go. And this is how you graph a function from given conditions.